Good day, viewers. You're welcome for today's tutorial. Today we'll be looking at fundamental and derived quantities in physics. What are fundamental quantities? Fundamental quantities are basic quantities that are independent of others for them to exist in physics. And these quantities are as follows. We have time, mass, length, current, temperature, luminous intensity, and amount of substances. In the other hand, we have derived quantities. These examples are area, speed, stroke velocity, acceleration, momentum, force, pressure, density, and volume of substances. Now, each of these quantities have their own units, and we're going to be looking at the units of fundamental quantities which are independent of other ones for them to exist. The first one we have here is time. What is the unit of time? Time is second. Second. The unit of time is second. And the unit of mass is kilogram. Kilogram. The unit of length is meters. Meters, or you can write M to represent meters. The unit of current is ampere. 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 That's the unit of current. The unit of temperature is Kelvin. Kelvin. For ampere, you can just use A as a symbol. Then Kelvin, you can use K to represent Kelvin. Then we have luminous intensity. This we use the unit is candela. And then amount of substances is in mole. Amount of substances is in mole. Yeah. So these are the fundamental quantities and their units that we'll find in physics. I when I look at this first one, time, mass, and length, that I love them so much because that they you use them in mechanics and you apply them more often as you proceed in your physics journey. In the other hand, we have derived quantities and units. So let's look at the unit of derived quantities. And what are derived quantities? Derived quantities are those basic quantities that are dependent on others for them to form. That is, they cannot exist on themselves. They need the life of the fundamental quantities for them to exist. It means that one or two of the fundamental quantities will have to combine for the derived quantities to be formed. So that is what derived quantities. They depend, they are dependent quantities. And these quantities are, one, we have area here. Area, the unit of area is what? Unit of area is meter squared. This is a rectangle. What will be the area of a rectangle? A rectangle has two lengths and then breadth. Yes, and then the two basic things you can find on the rectangle are length and length, breadth and breadth. So if you multiply the length and the breadth, it should give you the area of the rectangle. But in real sense, this is breadth. But actually, this breadth is is length because distance between 2 points is length. So that means you can say that this is also length. So if you multiply length and length, it will give you length squared. And the unit of length is what? From our derived quantity, our fundamental quantity, to say length is meter. So we can say meter and meter. This will give us what? Meter squared. So that's the reason why the unit of area is meter squared. Yes. So um, that is it. Speed, stroke velocity. These two, speed and velocity, they mean the same thing. But there's only one difference between them. Speed is a scalar quantity, while velocity is a vector quantity. That is the only difference between them. But they have the same units, and that unit is what? Meter per second. What is velocity then? Velocity is simply defined as displacement over time taken. That is, velocity is equal to displacement d over time. And displacement is calculated in what? meters. When you displace a particular quantity, it moves a distance. I mean that distance is meters, right? And so if you can say that a distance is calculated in meters and then time is in seconds, then we have that velocity in unit is meter over second, and we can write this as v is equal to m s, or you can say m over s. It's the same thing. So that's the reason why we have the unit of velocity to be equal to meter per second. And third, we have acceleration. Acceleration is simply defined as the change in velocity over time taken. Acceleration, change in velocity over time taken. When velocity change over time, we have acceleration. And the unit of acceleration is meter per second square. Meter per second square. Or this can be meter per second square. This velocity too, you can say ms and 1 is the same thing. How do we get the unit of the acceleration to be meter per second square? Simply because we say that acceleration is change in velocity over time taken. That means acceleration A is equal to the v change in velocity, that is velocity over time. And we have already known that the unit of velocity is meter per second from here. So if you put meter per second divide by what? Time. Unit of time is what? Second. Then we can have that meter per second per 1. So when you reciprocate this will come up here and this will multiply this. So you will be having ms squared. That's the reason why we have the unit of acceleration to be meter per second square. I hope you're following us. Okay. So the next online we have momentum. Momentum is simply defined as the product of mass and velocity. The product of mass and velocity. So we can say that momentum is equal to the product of mass and velocity. And so to find the unit of momentum, mass we know is calculated in what? Is in kilograms. From fundamental quantity, we say that mass is unit of mass is kg. So you can say that kg multiplied by the unit of velocity, you have already known it to be here, meter per second. It is meter per second. So therefore, we have the unit of momentum to be equal to kilogram meter per second. So we have the unit of velocity to be kg meter per second. That is kg meter per second. That is the unit of momentum. The next is force. Force from Newton's second law is defined as the product of mass and acceleration. From Newton's second law, those of you that you are in SS1, you're just coming, you may not have understanding about that, but as we proceed in physics, you're going to know about that very soon. But our big guys, you know that Newton said from his second law that force is equal to ma. Why? That is the product of mass and acceleration. And so to find the unit of force, we can say that the unit of mass here is what? Kg, right? Multiplied by acceleration is meter per second square. So if we multiply this, we can find out that the unit for force is equal to kg meter per second square. You can also say this is equal to Newton because kg per Newton square is the same thing as Newton. This is in honor of the person who found this. So we can say it's either what? Kg meter per second square, that is kg meter per second square, or what? Newton. Anyone you use at the end of the solution, if I ask to calculate the force, you are correct. Yeah. So the next we are going to look at is the pressure. Pressure is simply defined as force over area. Yeah, force over area. Pressure P is equal to force over area. If you have to hit, if I have to break your coconut or anything, you apply force over the area, and you see that the coconut will break. That is whatsoever thing, or maybe you want to push something. If you apply force when you push anything you want to push at all, you see that the thing takes a move. So the area of the particular object you apply force on it to cause pressure. So now we have that pressure is equal to force over area, and we know the unit of force now. Therefore, we can say force is Newton, and divided by area is what? Meter square. So we can say that pressure is equal to Newton meter per meter square, and this is the same thing as Pascal. Pascal. Let me write it very well. That is, pressure is equal to Newton per meter square, or Pascal. Pascal. Yeah. So from this, we have seen that pressure, the unit of pressure is Newton per meter square, or what? Pascal. Pascal. The last, second to the last thing, we have density. Density is simply defined as mass over volume. Mass over volume. Density is represented by the sign rho, and is given as mass over the volume. And to find the unit of density, you find the unit of mass. Mass is what? Kg. Divided by volume is what? Meter cube. So we can have that the unit of uh, of density is kg per meter cube. kg per meter cube. That is the unit of density. That is kilogram per meter cube. And the last but not the least, here we have volume. And volume of the substance is a unit as a unit of what? Meter cube. Yes. So these are fundamental quantities and derived quantities and their units. If you find this video interesting to you, please like and share, and then you can also follow our follow us for more. Thank you.